And we're back to conclude 15-2, homogeneous aqueous systems. In this podcast, we're going to take a look at the amount of water that's in a hydrate, and we're going to express it as a percentage. All right, so percent water in a hydrate, any percentage, and let's go ahead and get my pen ready. There we go. The percent water, just like any percentage, is going to be the part divided by the whole. Times 100%. And so the part that we're talking about is the water, so it's the mass of the water that's in the hydrate, divided by the whole mass, which is the mass of the total hydrate, which includes the compound and the water. And of course, you multiply that by 100% to get it into a percentage. So let's go ahead and calculate the percent by mass of water in washing soda, which is sodium carbonate decahydrate. So the percent water, percent H2O, will equal the mass of the water. Well, the mass of the water is going to be 10 times the molar mass of H2O, which is actually 18.02 grams per mole. So that's going to be the mass of the water in that compound. The total mass is going to be the mass of the sodium carbonate, which is going to be 2 times 23 for the sodium, plus 12.01 for the carbon, plus 3 times 16 for the oxygen, plus, you have to include the water, 10 times 18.02, and so that is the total mass of the hydrate, times 100%. Now if you want to simplify this, you can. This would be 180.2 grams divided by the total, which is going to be 286 grams, times 100%. And when you perform that calculation, you get 62.9%. So almost 2/3 of this compound is in fact water. Okay? Let's try another one. And feel free to pause this if you want to try this one on your own, then restart it to double check yourself. We're going to calculate the percent by mass of water in calcium chloride hexahydrate. So again, your percent water will be the mass of the water, which is going to be 6 times your 18.02, divided by the total mass of the compound. Calcium is 40.08 grams per mole, plus you have 2 chlorines, which are 35.45 apiece, so we multiply that by 2. And then you also add in your water, 6 times 18.02. Put that entire denominator in brackets, times 100%. And so if you take your 6 times 18.02, we're getting 108.12. When you take your 40.08 plus your 2 times your 35.45 plus your 6 times your 18.02, I'm getting a total mass of 219.1 for the mass of the hydrate. And then you multiply that by 100%. So 108.2 divided by 219.1 times 100. And it looks like it's 49.4% water. So not quite half, just shy of half of that compound would in fact be water. We'll be taking a look at that in lab. Other than that, that concludes 15.2.